Today we are working on solving systems of equations. There's a couple of different ways to do this, but unfortunately we only have time to focus on how to solve these graphically, given our time before our district test coming up here. So it should be a really quick, short lesson today. But basically a system of equations is going to look something like this. If we type in, and please pull up Desmos so you can do this along with me and know how to work through this. If we type in an equation into our equation side here, let's call it y equals x plus 2, we're going to get some line. And this line represents the relationship between y and x. If we were to then type in another equation here, let's say x equals -3, here we get some other line. Now, the solution to these two equations, or this system of equations, these multiple equations, is where the lines intersect. Notice how the red and the blue intersect right about here. If we hover around that point and click on it, we'll see that it intersects at -3, -1. And that means the x value is at -3, right? If we count over from the left, 1, 2, 3, and the y value is at -1. We might also uncover systems that aren't straight lines. Okay, we've been dealing with polynomials, quadratic equations. So let's see what one of those might look like. So if I plug in y equals x squared minus 2x minus 3, we'll get a quadratic equation that looks like this. And notice how when we type in our exponent, we'll want to use shift 6 in order to get that small exponent letter up there. And for a second equation, I'm going to type in another linear equation. Let's go y equals 2x minus 3 here. Okay, and if we look at this graph, the lines intersect twice. They intersect once down here at x equals 0 and y equals -3. And they intersect once up here at x equals 4 and y equals 5. So we're often going to get this where we have two different solutions to the quadratic and linear system. Now, depending on how these lines intersect, we might also only get one solution. Let's look at if I plugged in y equals -4 here. Notice how as my purple line hits, it only touches the bottom of my parabola or of my quadratic function. It only has a solution of 1 and -4. Okay, we could also get, let's say we shifted this down one more unit at y equals -5. We can get a situation where there's no solutions. There is no intersection between the quadratic line and the straight line here. So that would be a no solution scenario. So for today's problem set, for today's exit ticket, we are going to solve systems graphically simply by typing them into Desmos like I showed you and finding those intersections. Before we do that, though, in practice problems, let's first just kind of summarize what we're looking for, how we're going to represent our problems. So in your notes section here, there's a couple instructions on how to solve linear systems of equations. First thing we want to do is find the intersection graphically, then write the coordinates as an ordered pair. So for an example, when I say ordered pair, if I am given x equals 4 and y equals 8, we are going to write our answer as parenthesis 4, comma 8. Just like you write a coordinate on your graph. All right, and there's two scenarios we're looking out for when we're given linear systems. So this will have two straight lines. There's going to be one solution where our lines intersect, okay? So if you look here, we have a straight line at at x equals -3. We also have another straight line. It looks like they intersect at x is -3 and y is -1. So we would write our answer as -3, comma 1. But there's only one solution there. We also might get a situation where we have two parallel lines. Notice these two blue lines don't ever cross. Okay, so they're not going to have any solution whatsoever. Moving on to talk about the quadratic and linear systems that we explored in the second Desmos example. It'll depend on the number of intersections that we get. Okay, so we might have two solutions, we might have one solution, or no solutions, depending on kind of how those lines interact with each other. But we do want to seek out and make sure we check for every intersection because we might have multiple when we get a linear and quadratic system. So using this knowledge, using Desmos to input our graphs, you can go ahead and start practicing this on our problem set for today.